Simplifying radicals, take 2. All right. First of all, we got to talk about what a radical is. We talked about this a bit yesterday. Okay? A radical is any expression with that symbol. Okay, you guys know it as the square root symbol. We talked about it yesterday, how it's more than the square root symbol. Okay? That is the radical symbol. All right? If it's got that in it, then you're dealing with a radical expression. Okay? What does it look like in math? Well, in math, we need a number under there and a little number up here. Yes? I told you the names of those yesterday. We're going to rewrite them today. What it officially looks like is this. X, because we can have any number there, and Y, because we can take a root of any number. Everybody cool? Everyone okay? All right. Does anybody remember what the X is called? I told you yesterday. Index. And that tells me the group of factors I need, right? And Y is what we call the radicand. And the radicand is the number we factor. Everybody cool? Everybody cool? Okay. An entire radical looks like this. X root Y. There's nothing there but the radical. Everybody good? Just like a fraction. 1/2 is a fraction, right? And it's a fraction. What makes a mixed fraction? Or a mixed numeral? That is an improper fraction, but to make a mixed numeral, we put a number in front, right? Same thing here. A mixed radical is this. Z, so some other number, then the radical sign. Everybody cool? Now Z is a big number bumping right into another math thing. So what math happens right there between the two of them? Multiplying. Because Z is a coefficient. And you all remember what that is. Like 2x means 2 times x. So this means Z times this radical. Is everybody cool with that? Everyone is good? All right, let me make sure if you're really good. You don't have to write this down. What is 6 root 4? What does that mean? It is 12. Why? Because it's 6 times the square root of 4, which is 2. So 6 times 2, and we get 12. Does everybody understand mixed radicals? How to read them? Everyone's cool? Okay. Now, next thing we're going to do is we're going to simplify. Now, you guys are smart kids. What happens to the value of something that we simplify? Think about what I just said. What happens to the value of something we simplify? It stays the same. So what happens when we simplify? What is the point of it? To make the numbers simpler, which means what? Smaller, generally, in math. Does everyone agree? And here's what I mean by that. If I give you, don't write this down, 75 over 150, and I tell you to simplify it, can you? What is it? That's 1/2. Did the values change? No. But it's real easy to say, hey, let's split that pizza. I'll take half, you take half. Right? That's a lot simpler than saying, hey, Nacho, let's split a pizza. I'll take 75 150ths of it, and you take the other 75 150ths of it. Okay? Everyone understand? All right. So here's what we're going to do. Remember how in the first unit we started using pi as a symbol, and we stopped using 3.14, right? Right? Okay. Up until grade 10, if you were faced with the square root of 72, what is the only thing you would do with that? With what device? Your calculator, because there isn't a square root of 72, is there? So if I say to you, hey, what's square root of 72? You'd go square root 72, get 8.485, and so on. Everybody right? That's what we do, agreed? That's not what we do in math anymore. Why? Can anybody guess? It's not perfect. 8.485. How long does that decimal go, Mikey? Forever. So does it really even exist? No. And we don't like that. So what we do in math and in physics now is we go for exact answers. And we can find those exact answers by using math that you guys already know. All right? So we're going to look at this situation here first. And we're going to say to ourselves, self, how can I make this simpler? Step 1 is factor the radicand. So what is the radicand in this expression? 72. We got to factor it. When we factor it, will the numbers be smaller? Yeah, and that's our goal, to simplify, right? So you guys factor 72 however you like to factor. Do you like trees? Do you like sideways trees? I factor this way. 72. Since I know that divides by 2, I'm going to do 2 into 72 and get 36. Then I'm going to go 2 into 36 and get 18. Then I'm going to go 2 into 18 and get 9. Then I'm going to go 3 and 3. That's how I do it. You guys have whatever method you use, but all of you are capable of factoring 72, yes? Is there anybody in the room that does not understand now that 72 is the same as 2 times 2 times 2, which is 2 cubed, times 3 times 3, which is 3 squared. 8 times 9 is 72. Is everyone okay with what I did there? You don't have to be able to do it yet, but I need you to understand what I did. Is everyone all right with that? Everyone can see how it works? It's the factoring that we've already done when we're doing GCF and LCM. We're just going to do something different with it. Everybody is good? Yeah? Okay. That is step 1. Step 2, we remove groups from the radicand. Okay? Now, I haven't shown you this yet. We got to think about that. Which number in a radical tells me how big a group of factors I'm looking for? The index. Absolutely. I haven't written an index here. So what is the index? 2. Because the square root is the smallest one we can take. You can't take a 1 root because that's just the number. Got it? So when there's no index, what's the index? 2. It's the only time in math that that happens. Usually we don't write 1s. And when we don't write a number, it's a 1, isn't it? But in this case, it's a 2. So my index is a 2, which means I must be looking for groups of 2. Agreed? Look under that radicand. Do I have any groups of 2? Three squared. There's 2 3s there, isn't there? So that means I can take out a 3. So I'm going to take that 3 out here. So now I've got 3 root something. Yes? Is there another group of 2 in there? Yeah. Where? In the 2's. There's 3 2's there, right? Can I take 2 of them out? So I'm going to bring a 2 out. Did I leave anything under there? 1 2. Now you guys are smart kids. 2 numbers out in front, they're both coefficients. What do coefficients do? So what do I do with 3 and 2? To get 6 root 2. And that, in grade 10, is where we stop. Okay? Is everyone cool with that? I'm not asking you to know how to do it yet. I'm asking you to recognize every step we took. Is everyone okay? All right. So let's see if you guys are okay at this. We got 99 here. Step 1, factor the radicand. What is the radicand? 99. So I take 99 and I factor it. However you want. Okay? Go. I'll do a tree this time because most of you like trees. Does everyone agree that that is what the tree looks like? Everyone cool with that? So now we rewrite. It's 3 squared times 11, yes? Everyone cool? Is there a group of 2 there? Where? 3 squared. So out comes what? A 3, and what stayed under there? 11, because 11 didn't have a partner. And we read this as 3 root 11. Is everybody cool? Everyone's good? All right. It is. It's radical. Because Bryce just said it was gnarly, so I said it was radical. Get it? The guys that don't speak English are like, what? Gnarly and radical were slang from the 80s. If something was cool, it was gnarly. And if something was cool, it was radical. You want to know some others? Just for fun? Tubular. If something was cool in the 80s, it was tubular. I'm not joking. Want to know another one from the 80s? Beige. If something was cool in the 80s, that's beige.
Maybe you didn't know that one.
Yes, few people do.
Apparently few people were that cool.
No, few of you were alive in the 80s, as in none of you. All right, so let's look at the next one. What's the first step? Factor the radicand, right? So what would you divide 75 by?
5.
You would use 5? 5 would be 15. Then what would you divide 15 by? 5 again. And what would you be left over? 3. Is there a group of 2 there? Where? The 5. So what comes out? 5. And what stays under there? 3. And it's done. Does everybody see what they're doing? Okay. I want you to try 80 by yourself. And then I'm going to give you a shortcut that will help you, but not until we get to D. So everyone try 80 on their own. Factor it any way you see fit. Is everybody okay to this point? 2 to the 4th times 5. Is everyone cool with that? Okay, now, are there groups of 2? How many? 2, because I can take out 2 groups of 2, can I? So out comes a 2, out comes another 2, and what did I leave under there? 5. What do I do with the exponents? So it's 4 root 5. Is everyone cool? I'm about to say that. Here is the first trick I'm going to give you. Notice 2 to the 4th became 2 squared, didn't it? This is also 2 squared, yes? Please notice that 2 to the 4th became 2 squared. 3 squared became 3 to the 1. 5 squared became 5 to the 1. So what's the shortcut when you're doing square roots? If you have a 4 there, it became a 2 out here. What if you had a 6 there? What would it be out here? 3. What if you had an 8 there? 4. What if you had a 12 there? 6. Does everybody see how it works? Will it work with odd numbers? No, unless you leave the remainder. Understand? That's trick 1. I'm going to show you trick 2 right now. 300 is starting to get to be a big number, isn't it? What is this question asking me? This is asking me for the square root of 300, correct? Does 300 have a square root? Well, no, because it goes 289, then 324, right? Everyone agree? But isn't 300 also the square root of 3 times 100? It is, isn't it? Doesn't 100 have a square root? What is it? What? 10. So what's the square root of 100? 10. So what can I bring out? 10. What did I leave under there? 3. Remember how yesterday I told you if you have the first few perfect squares memorized, it will really help you? Here's where it starts helping. Now, could we do this the long way? Would it still work? Sure it would. Watch. 300 divided by 2 is 150, divided by 2 is 75, divided by 5 is 15, divided by 5 is 3. Is there a group of 2? So out it comes. 2. Is there a group of 2? So out it comes. 2 times 5. And what did we leave under there? 3. What's 2 times 5? 10 root 3. And see how they're the same thing. Is everybody cool? So if you know the perfect squares, you can stop anytime you get to a perfect square. Understand? So let's look at this first one. 63. Can you guys think of a factor of 63 that is a perfect square? 9. Because 63 is 9 times 7, isn't it, Josh? Does 9 have a perfect square? 3. So what's coming out? 3. And what did we leave under there? 7. Everyone see how it works? Could Josh do the long way? Could he go, okay, 63 breaks down into 9 and 7, which breaks down into 3 and 3. Oh, there's my pair. Will it still work? Yes. But it's helpful if you can find a square root. What about 32? Does it have a square root that's part of its factors? 16. Isn't this the square root of 16 times 2? Does 16 have a square root? 4. So what's coming out, Josh? 4. And what stayed under there? 2. Can we do it the long way? Sure we can. 32 2, 16, 2, 8, 2, 4, 2, 2. There's a group of 2. There's a group of 2. 2 groups of 2 gets me 4. And what did I leave under there? This last single 2. Everybody see how it works? I could also have written it this way. The square root of 2 to the 5th, couldn't I? 1, 2, 3, 4, 5, yes? And I know I'm going to divide that number by 2 to get out 2 squared, and I'm going to leave 1, 2 under there, because that's the remainder. Is everyone cool? So 363 is a bit harder. If you don't know, you're going to have to factor a bit, right? If you factor a bit and find a square, can you stop? Sure you can. What would be the first thing you would try to break 363 up with? Will 2 work? Why not? Because it's odd. So will 3 work? Sure. 3. How many 3's fit into 3? 1, 21. Can I stop now? Why? Because 11 times 11 is 121, isn't it? So do I know the square root of 121? It's 11, so what comes out? 11, and what stayed under there? 3. Is everybody good? Yeah? Okay. We're going to add a layer now. Everybody is comfortable with when stuff comes out, right? Okay. Now we're going to put stuff back. If there's a single 2 out here, what does that mean there was under there? There were 2 2's, right? So this 2, if it goes back under there, had to be 2 2's, didn't it? What is 2 2's? 4 times 5. So this becomes root what? 20. Does everyone see how that works? Now let me show you a shortcut. What should the index here be? It's not written, so what should it be? 2. 2 squared. Oh, it tells me what to put back under there. Because 2 squared was under there, wasn't it? So what's this one? 7 square 29. If there's 1 7 out here, how many 7's were underneath? 2. So it becomes 29 times 7 squared. You can't do that in your head. What's the answer?
1421. 1421.
Closer to being the right way to say that number. 1,421.
1421.
1,421.
I used to say thousands in thousands. I want to say them in hundreds. It's just how my family says it.
British. Everybody cool?
I don't think that's a British.
Yeah, it is.
Is it?
Oh, totally is. All right, 6 and 4. How many 6's had to be under there? If there's 1 out front, how many were under there? 2. So this becomes what? 4 times what? 6 squared, which is 36. And it is 144. Holy crap. Now, look at D. You have to think about grade 9. What is out in front? Is it a 5 or is it a negative 5? What? Think to grade 9 exponent law. It's just a 5, isn't it? So what's going back under here? Not 5. 2 5's. So this is 12 times 5 squared, yes? Which is 300. But what is missing from my final answer? Where does that negative have to go? Out in front. Because this negative tells me everything after it is negative. Is this still true? Yes. Here's why. Don't write this down, but you all remember from grade 9, what is negative 2 squared?
4.
Is it? It's negative 4. What's negative 2 squared? That one's 4.
Dang it.
Why? Because the brackets include the negative in the base here. Remember that? Everyone cool? All right. Now, let's see if you guys can really do it. Look at 3A and tell me what looks different about it. It's got an index of 3. So what am I looking for now, Josh? Groups of 2 or groups of 3? Groups of 3. Do you think anything else changes? No. So what's our first step? Factor. Factor what? 54. Well, let's factor it. I'm going to go 9 and 6. 3, 3. 3, 2. Is there a group of 3? Which one? The 3. So what comes out? The 3. And what stayed under there? The 2. Nothing else changes. Everyone got it? Okay, so let's look at B. What size factors do I need? What size group? 3. Does anything else change? Nope. 144, we factor it. I'm going to go 12 and 12, 3 and 4, 2 and 2, 3 and 4, 2 and 2. And I see that I have 2 to the 4th and 3 squared. Do you see any groups of 3? Where? The 2's. But I'm going to have to leave one under there, aren't I? So what's coming out? 2. And what do we leave under there? A 2. And how many 3's? 2 3's. Is that simple? Really? So if I owed you $18, you would rather say, hey, Josh, I have 2 times 3 squared dollars for you.
I want to do it, but it's harder than that.
Exactly. So would we leave it like this? No. We 2 cube root 2 times 9, 18 for a final answer. Is everybody with me? Okay, look at C. What's different? Oh, Navjot, your hand. No, the index number just tells you how big a group you're looking for. Now, look at C. What's different? It's a 4. So how big a group am I looking for? Groups of 4. Does anything else change? No. So 128, 2, 64, 2, 32, 2, 16. And I am going to stop there. Why? What do I know about 16? 4 times 4, which is 2 times 2 times 2 times 2, isn't it? So isn't this a group of 4 right away? Because 16 is 2 to the 4th, yes? Is that a group of 4? So if I don't know that, can I continue? But if I do know that, I can stop. Do you understand what I'm saying? So if I were to continue, I would just go all the way down and count. Oh, there's my group of 4. Everybody with me? So what comes out? Just the 2's, and what stays under there? 2, 2, 2. Which is 2 cubed, which is what? 8. Is everybody Gouda? Everyone is Gouda? All right, you guys try D, E, and F on your own.
I couldn't hear you.
No, because it's deaf. But it's D, E, F, which is more 80s slang. That's deaf. No. Deaf meant good, like Def Jam recordings. It's a rap thing. Sadly for the world, they didn't mean it ironically. Because if everybody were deaf, then maybe nobody would listen to rap and we wouldn't have to put up with it.
Yes.
That would be great. But it's probably not going to happen. These people still want to hear about, that stuff. Which is why Lord's song is so good, because it makes fun of that. So while you guys are working on these, I'll put up the right answer, but I'm not going to walk you through it. You just keep working at your pace, okay? I'm just putting up the right answers. That isn't right. Oh, that is right. When you're done, check against mine, make sure you've done it right. If you haven't, you need to ask me so I can show you. Does anybody need to see one of them again? Which one? Which one, Mikey? Okay. So what's the first step? Always. Make the tree. So 162 divides by 2 to get 81, yeah? 81 doesn't divide by 2, but it's 9 and 9, isn't it? 9 and 9 is 3, 3, 3, 3. Is there a group of 4? So it comes out, and what did we leave under there? The 2. Cool? All right. Did anybody want to see either of the other ones? Which one? F. Okay. What's the first step now, Joe? Factor it. So 108 factors to what? There's a lot. 12 times 9, yeah? 3 and 4. 2 and 2. Cool? 3 and 3. Right? What do I need? Groups of what? Groups of 2. Is there a group of 2? So out comes a 2. Is there a group of 2? So out comes a 3. Coefficients multiplied together. What did I leave under there? That 3. 2 times 3 is 6, so it's 6 root 3. Cool? Everybody good? Yes?